Okay, so very good evening to everyone. Thank you so much for me to giving this opportunity to meet you all. So myself, I'm Dr. D. Samuel Spurgeon, heading the R&D division in Sahasra Crop Science from Hyderabad. So I've chosen this lecture for this 15 days wonderful training program in the theme of trending novel technologies in agriculture. So my topic will be the current research trends in nanotechnology for sustainable agriculture. So we all know, so because we are the agrarian economy, and but we are facing a lot of challenges, agriculture sector. So increasing population, reduced land area, investments related to and pesticides day by day increasing, and along with that one, environmental issues. So again, day by day increasing, and one of the most priority and very devastating is pest management. So these are the ever increasing challenges for the agriculture sector, not only India, globally. So what is things? Actually, there is a innovative technology or methodology we are using, nanomaterials. We're all nowadays hearing the nanomaterials, nanotechnology, and all these things. So first of all, I would like to know, so what is nanomaterials? So though there are several definitions from different statutory bodies throughout the world, so according to the European Commission, the nanomaterial is defined as a material that is natural, incidental, or manufactured material consisting of nanoparticles. So it can be a natural formation or any incidental or through manufacturing. And the nanomaterials are smaller than 1 micrometer in one or more dimensions. And the materials are derived from different sources, such as, that's what, as I said, it can be a natural or incidental or engineered. So these are called as nanomaterials according to the European Commission. So now we'll come to what are the natural nanomaterials. So what we think whenever we are talking or reading about nanomaterials, we'll think of very hi-fi rocket technology. So, but in our daily using materials, seeing materials, there are so many nanomaterials. So like one, volcanoes, ash, or any mineral sprayings, even dusty storms, ocean sprays, and mineral springs, even viral capsid proteins. That means every virus will have the capsid proteins. Those are also natural nanomaterials. Even spider silk, this whatever the web, spider will wave that silk also from the nanomaterials. Waxy outlayer of the lotus plant, our national flower lotus. With that, if you see we all know the waxy outlayer of lotus plant is also because of the nanomaterials. Whereas natural colloids and even plant extracts, microbial extracts, redox active secondary metabolites, milk, proteins, peptides, all these comes under natural nanomaterials. Whereas incidental nanomaterials, so these are produced by industrial process and mechanical processes. The sources of nanomaterials produced in this category are vehicle exhausts or combustion processes and welding fumes. These things we are facing every day. We will be seeing on our daily basis. The best examples under this category are burning gas, candle and biomass. These ultrafine particles contribute to the air pollution. So we know that only due to suppose if you take the burning of carbon fuels like carbon monoxide, carbon dioxide. So they have direct effect on us. Along with that, actually, we are not aware that recent studies are saying that because of, along with that one, ultrafine particles, which are affecting more on our health directly. Now, after knowing natural and incidental nanomaterials, we have to know engineered nanomaterials also. The nanomaterials are engineered and manufactured to cater to the needs as well as the required properties. The nanomaterials that comes under this category or carbon nanotubes, I think you might have heard that one, and metal oxide nanoparticles and quantum dots. These are the, ruling nanomaterials in the nanotechnology. So the engineered nanomaterials have novel properties due to its surface area. So why we are very crazy about nanomaterials? Because they are having a novel properties, because its surface and its particle size and its reactivity on surface and presence of coatings and surface charge, what they are having. So these properties, these novel properties makes these nanomaterials very unique. So, okay, I'm talking about the nanomaterials or nanoparticles. So just for your idea, so what will be the nano? I think you might have, seen so many things. So if you take the tennis, ball, and if you take the ant and human hair, so what will be this one? Atoms, molecules, DNA. So generally, it should be 1 nanometer to 100 nanometers. Under that category, so whatever it is coming, they will be considered at it as nanoparticles. So in general, 1 nanometer to 100 nanometers. I think it is, if I'm not wrong, 2 nanometers to 100 nanometers. These will be, and again, it depends on different bodies and their definitions. So most probably it will be considered from 1 to 100 nanometers comes under nanoparticles. And furthermore, for better understanding, because we are talking about the agriculture, and so when you are spraying, and if you are going for a foliar spray, either nutrient or pesticides or anything, we will generally will prefer foliar spray. So if you spray, if you think water droplet, it will comes under 2 micrometer, and if droplet size is like this. This is you take it as a ideal leaf area. In that ideal leaf area, if you got these this much size will be 1 micrometer, and very sprinkler, if you use sprinklers, and then if you see very small droplets, it will be 500 nanometers. This is the 500 nanometers. Similar way, if you are spraying insecticide or any pesticide or any insecticide, then it will be like this. If it is a nano, you can see why we are going for this nano. So the absorption will be more, because the penetration into the, that outer barrier or cuticle or whatever the plasma membrane, it will be more easy when compared to the larger materials or molecules. So you can see the difference, even in case of nutrients or in case of pesticides also. That is the major difference between the normal or conventional material and nanomaterials. So now I think all you have, those who are, not aware earlier. So I think, I hope you got some idea about the nano size. So nano size and types of nanomaterials. So let us go in depth in the nanotechnology, which is the future of the agriculture industry. Of course, not only agriculture, but I'm taking agriculture industry along with this one. So nanotechnology and its intervention in the sustainable agriculture. So Here it plays as I said, it plays a vital role in the agriculture field at various stages, starting from water storage, delivery of nutrient, and management of the pest. In my previous slide, you might have seen delivery of nutrients. It is very easy when compared to the conventional molecules or nutrients. Similarly, the management of the pest with minute or with minimum quantity of pesticide or minimum quantity of nutrient, you are able to meet your crop requirements that will ease the farmer, or that will decrease the output, production cost of the farmer. Excuse me. So for, getting, or for when we are aiming the sustainable agriculture, these are the very critical points, and which will be meted by this nanotechnology. So in overall view, holistic view, if you see nanotechnology in agriculture, so from starting onwards, so crop improvement and their nanobiotechnology, how it will improve. So for transgenic plants, or speed breeding, or so these aspects will be covered in the nanobiotechnology. And if you are coming to the crop protection, so that's what now we have discussed. So it can be nanopesticides, which will be very huge demand in the market, and it is the need of the hour for the globally. And precision farming. So now recently we are talking about, and we are seeing about precision farming, especially in hydroponics and or polyhouses and vertical farms. We are seeing several things. Now we are entering into the sensors and artificial intelligence, Internet of Things, and so many things, which will be very much required of these nanosensors. These are very good example for precision farming. Similarly, if you go to the stress tolerance, so which are again, earlier slide I've said the water management, why we need this nanoparticles. So it will relieve the drought conditions, not only the drought or heat stress, or salinity stress, or alkalinity stress, or even UV stress. So it will relieve from these stresses, which will be very important, especially arid lands and all these conditions, dry land areas. Similarly, soil enhancement, which will improve the soil structure and their water use efficiency and water holding efficiency, and their microflora. So these are very important by using our nanomaterials. Similarly, nanofertilizers. So now these days we are listening, or we are hearing about nanofertilizers. I think you might have known that IFCO has released nano urea. So that is one of very good example of nanofertilizer. Similarly, there are several others coming forward with nanofertilizers, and very soon we are going to get nano DAP. So these are all the recent trends we are seeing in our daily life. So which will improve the germination, plant growth, yield. So from seed to production, and from soil to fruit. So for everything and holistically, so the nanotechnology is playing a very good role in agriculture very soon. Already we have started, so it won't take much time to get in depth in the agriculture. So as I said, different nanomaterials are there, and different forms of nanomaterials are there applied in agriculture. So there are mostly, there may be more also, but I've categorized into 7 as per their requirement and their importance in agriculture. So one are nano carriers, second one is nanotubes, nano clays, nano composites, nano sensors, nano fibers, and nano capsules. So these are all different forms of nanomaterials which will be used in these, different scenarios of agriculture. So improving the uptake of active agricultural ingredients is necessary for minimizing biotic stress and enhancing yield. So that is the primary object of nanomaterial. So it is assumed that only 0.1% of applied crop protection agents, it's a global data based on the global data, so reach their biological target, whereas the majority are lost to the environment. So imagine the huge or vast amount of pesticides or insecticides, whatever we are using, and 0.1% is only targeting the pest, and remaining we don't know where it is going, and it is becoming the part of the environment, so which causes a huge health concern for the today's society. So this is the high time to think about it. So that is the reason, to reach their target, agricultural ingredients are applied to crops either by irrigation or directly to the foliage. So these are the two ways to target our, our scenarios. So one is foliar feeding. Circumvents problems associated with soil penetration and biodegradation. So yes, of course, in some way, the foliar feeding is very important. It as here it will circumvents problems associated with the soil penetration and degradation. Similarly, the efficiency of foliar application strongly depends on absorption and mobility. So of course, that's what I'm telling is a foliar application is good at some point, but there are some strong, some hurdles, like it depends on other factors like absorption and mobility, where in many cases both requirements are lacking. So we feel that if you spray on foliar, so it is we can't take it as a granted. We have targeted our whatever we are targeting. Similarly, for the foliar feeding to be effective, agricultural products or ingredients or any molecules must penetrate the leaf barriers. So this is the primary necessity of anything which we are when we are targeting foliar. So agricultural ingredients. So within mesophyll tissue are to be transported to other plant regions through vascular bundles. I think you might have know all those things. So translocation beyond the leaf is mediated by apoplastic. I think if you are aware, this will be through xylem and phloem. If it is nutrients, or the translocation is, if it is through xylem, we will call it as apoplastic, or if it is through phloem, we'll call it as a symplastic pathways. So one agricultural ingredient enters the cell. So it usually targets an organelle, typically initially the chloroplast, or affects metabolic processes in the cytoplasm. So modalities designed to improve delivery to the whole plant are necessary to address gaps in agricultural research and practice. So nano carriers hold great promise for bridging this gap. So you might have understood what is the gap in foliar applications. What is the need of nano carriers? So it will bridge the gap to get into the cell. Bridging this gap of barrier plant. Leaf barrier. due to their ability to carry complex payloads. So because as we said, they have a very typical characters like their charge, their shape, and their surface area, so their size. So because of that, they have a very great ability to carry any complex payload. You can give a very good molecule of pesticide in minimum quantities or any nutrient through these carriers, so we can target easily our requirement. As I said, so if you think about a symplastic pathway, how it will go through phloem mediated or xylem mediated, you can see that. So this is for your better understanding, representative slide which is available in the public domain. So now we are discussing about the nanocarriers, right? So in these nanocarriers, so nanocarriers, polymers we'll call, and carbon-based nanomaterial, micelles or liposomes. You can see the nanomaterials act as a carrier system for the delivery of agrochemicals. So the encapsulated material deliver chemicals, growth regulators, and micronutrients in encapsulated form. So these are the different types of nano carriers which will be having. First and foremost, we'll discuss about the liposomes. So the vesicles with an inner aqueous core. You can see this is the inner aqueous core surrounded by a lipid bilayer, or widely used as carrier for medicinal small molecules, proteins, and nucleic acids, liposomes, which are stable in aqueous environments. So which will be where we are, the molecules or whatever we want to send, so which are stable in aqueous environments, we will choose these liposomes as a carriers. So subsequently fused to the plasma membrane or are internalized by cells through endocytic and signaling pathways. So you can primary liposomes which are using in medicine. So you can better see how it will be carried. So suppose any nutrient, it will be in this one, which is soluble in the aqueous and with in no interference of aqueous environment. If it is, then you can load your nutrient in this aqueous inner core, and this will be hydrophilic head, and this is hydrophobic tail. So this is a very great representative picture for your better understanding the structure of the liposome, how it will be. And using this liposome, one of the scientists they worked a very good research how they have, they have given magnesium through this liposomal. So you can see the difference in how it is in control, and with just free magnesium sulfate, if they've added how it has, and free magnesium sulfate for chelate, if you add how it is, and liposomal and magnesium sulfate with the carrier, how it has see the leaf structure. So and similarly liposomal magnesium sulfate plus ferrous chelate, how it has given. See, you can see this, it is a healthy and liposomal ferrous standard, and a free chelated and a free ferrous standard. If you see the difference, you will come to know that this one, and that canopy and their number of branches and leaf length, it is drastically and significantly varied. So this is also anatomical studies. So how the nutrients or nanoparticles in the plant system, they have, they are in the plant cell. So the advantages of liposomes. So carrier system are protected against degradation. So that lipophilic and lipophobic. You have seen outer layer is hydrophilic and inner layer is hydrophobic. So which will protect against the degradation and improvement in the solubility, because outer layer is hydrophilic, so solubility will be improved of substances, prolonged release, and inner core is hydrophobic, so it won't allow you immediately soluble, but slowly, gradually, that makes prolonged and sustained release of active ingredients with optimum concentration maintenance, which is very helpful in the medicine as well as in if you are addressing the any nutrient deficiencies. So these carriers will play a major role for sustained and prolonged release. So nanotubes. So I think we all heard actually, and we know these nanotubes and these structures also. You might have seen several times in TVs or papers, anywhere. When you are talking about nano or nanoparticles, we used to see these as a nanoparticle representative. So nanotubes are made up of carbon, which are cylindrical molecules with rolled up sheets of single layer carbon atoms. The carbon nanotubes are large molecules, 1 to 3 nanometers in diameter and thousands of nanometer long. So diameter wise, it will be 1 to 3 nanometers only. And if you take its length, it can be up to thousands of nanometers. Because of that only, there will be nanotubes are very much useful in textile engineering um, uh, and aerospace. There are much more applications of these nanotubes. The carbon nanotubes are extensively utilized in agriculture along with other field of applications, as I said, along with aerospace, defense, and engineering, structural engineering. So now there are major uses in agriculture also. So even carbon nanotubes are of two types, which include, you might have you can see here a single-walled carbon nanotubes and multi-walled carbon nanotubes. It can be after single, it can be 2 or 3 or 4 multi-layered. So there are different types of nanotubes. I think here you can see the carbon nanotubes properties here. This is a example of multi-layered nanotubes, because these are nano in size. These are having large surface volume ratio. That is very much important. Where this is one of the unique property. It has a large surface volume, and it is water soluble and electric properties. It is having a mechanical strength, highest mechanical strength. We can compare it to even diamond and even titanium. So because of that, they are using in aerospace. And biocompatibility. That is the major thing, because that is the major versatile factor which makes nanotubes in medicine. And higher immobilization efficiency. This is also very important, very critical point. And strong photoluminescence. These are the very prominent carbon nanotube properties. So there are different types of, again, carbon nanotubes. You can see helically coiled carbon nanotubes and different types. You can see, coiled, zigzag, a typical coiled or straight lines. So these are the different types of, carbon nanotubes. In agriculture, it is a very recent study from Sabdar et al. From 2020. So using carbon nanotubes, so how they have increased, germination and enhance how they increase the shoot growth or root growth. So both root length and number of leaves, photosynthetic rate, transpiration rate, everything has increased significantly, which is a very prominent factor of nanotubes. You can see shoot length, you can see the root length, and even the canopy or vegetative growth. So let us discuss about again the advantages. So in agriculture, the use of carbon nanotubes increases germination, as we have seen earlier, through the penetration of moisture into the seeds, which is very much important in seed germination. So the carbon nanotubes act as a vehicles to deliver desired molecules into seeds and protect the seeds from diseases. So if you use it as a seed dressing or a seed treatment, with how we are doing in conventional, let us come and discuss about the nanosensors. Targeting the light molecule. So the nanosensors diagnose the disease caused by plant infecting viruses, bacteria, and fungi. Nanosensors are used for the detection of soil-borne contaminants and also monitor environmental contaminants. The nanosensors are used for monitoring soil conditions such as soil pH, moisture. So, we are well aware of these things, especially soil pH and moisture, because people are already using these sensors. And nanosensors also detect pesticides, insecticides, herbicides, fertilizers, pathogens, and crop growth. These are also well versed with those who are in the food industry or from export industry. So these sensors are playing a major role for evaluating the quality of the food or produce. So how people are detecting, as I said, so with the nanosensor detecting the arsenic levels in plants, if you see, it will be, so if there is an arsenic in the plants, so with using the nanosensor, it will be very easy to evaluate us, to certify us, to locate the heavy metals using these nanosensors. So the advantages, if you talk about, the nanosensors are also used for detecting the soil-borne pathogens using the synthetic oligonucleotides or DNA probes or enzymes and antibodies and any others. So not only the detection mechanism, but the nanosensors also used in smart delivery systems for efficient use of monitoring water resources, nutrients concentration, and chemical concentrations. So which are very useful and very handy for agriculture. Those who are taking profession, agriculture for these nowadays corporate farming is coming way, and so many students or educationalists or technologists, everybody is coming back to the farming. It's a very good sign. So for them, initially it is very useful. So then I hope it will reach our single farmer from the last farmer as early as possible. And let us talk about nanocapsules, which will transport the bioactive compounds. So generally, when we are we're talking about the capsule, so initially one thing we'll get in our mind is the drug. What we are, on next day we are using for our well-being. So which will have drug in that capsule. So similar way, we will be encapsulated our required molecule or targeted molecule in that our capsule. So nanocapsule consists of an external polymeric membrane, and the inner part consists of liquid or polymetric matrix. It depends. So the inner matrix consists of bioactive compounds such as chemicals, genes, it can be herbicides, to target or to release whatever we are giving that molecule or compound to meet our requirement. The nanocapsules are synthesized by coacervation of or pregelation. These are the two procedures to make these nanocapsules. In this process, cross-linking, so of polyelectrolytes in the presence of counter ion will take place to form nanocapsules. So how that capsule will form, it's a very good study. If anybody interested in nanotechnology, and if they want to design their research area, or anybody is looking after their PG research or PhD research, they can think of it, because it's a very good interesting topic to work on. The nanocapsules are also produced by the polymerization of monomers. This is also very interesting to work on. The optimized process for the preparation of nanocapsules gives higher performance results. So how you are making that nanocapsules, so it plays a major role, and the matrix what we are using will lead you to the whatever you are targeting. So that is very important. So you can think of it how nanocapsules. I think this is a very very good picture to make you understand what is a nanocapsule, how it is built. So the polymer material used for the preparation of the nanocapsule are generally either it can be chitosan, zinc, casein, alginate, and sodium and tripolyphosphate. So that is what I'm just telling you guys. Actually, don't whenever you are thinking about the nanoscience or nanotechnology or nanomaterials, don't think it is a very unrealistic science or a very high-end science or rocket science. It is not like that. So any common lab, any college lab have alginate or chitosan. So these are available to everyone. Science students. So definitely they can work. Just what I suggest, just go through the literature of nanotechnology. It is not it is not impossible, or it is not that difficult, you think. So I suggest just to go through the literature available in a very good research articles. I'll suggest you to go through the reviews, recent reviews, so that you'll have from basic to advanced, you will have a very good holistic view what is nanotechnology. So this is how this nanocapsule will work in agriculture. So this is nanoparticles in polymer. If you're using nanocapsules, so if you're targeting insect, so if you're targeting any a nutrient deficiency, so it will be very effectively. You can target the deficiency or your or pest. So when we are when we discuss all these things, so when you come to the advantages, the micronutrient fertilizers are delivered into the plant to enhance the plant growth and crop yield. As we have discussed, the plant protection products are delivered into the plant in order to protect from plant associated diseases. And the nanocapsules release, even if you're doing with a herbicide, slowly in a controlled manner and reduce the impact on the environment, I think this is the high time to have such a product, such a nanocapsule with the herbicide, because you know that how herbicides have ruined the several lives, and how it is I don't name the company, but still we all know, and how it has made, lakhs of people through the globe to cancers. Let us, if nanoclays, so it is quite interesting. It is even for me also, when I'm studying or able to know these nanoclays. So these are natural materials, consist of mineral particles. So these majorly they will have silicates in in a form of layers, and also it's composed of elements such as silicon, oxygen, and other metal elements. So the nanoclays are formed as a multi-layers, and with the corner linked with the silicate tetrahedron. The layers absorb or dissipate water due to lack of bond between the layers, so which causes swelling or shrinkage of the clay materials. So very interesting. Property. So when if you talk about advantages, nano clays are like a talc or mica, kaolin sulfate, mount marlinite, and serpentine. Or nanoclays have water holding capacities and slow release of nutrients, which are again, these nanoclays are also very important for present situation. So because our soils become, our soils have lost their water holding capacity. So which is that is the reason actually nanoclays are also very important, especially in drought conditions. These nanoclays can be applied to convert the desert and de-desertification. Things are going around the world. So to make the to bring back the fertility of the soil. So the natural bentonite clays, I think we're all aware. Most of them are all aware of bentonite. And when we are using, if you are, granules of, especially in organic farming or somewhere, so bentonite granules are very much predominantly available in the market. So they are used for water retention and swelling capacity because it is having higher surface area and lot of absorption capacity. So those are playing a major role in agriculture. So nanoclay materials are used for the slow release of fertilizers. It can either nitrogen, phosphorus, or potassium to the plants compared with the conventional fertilizers. So these polymers materials are used for the sequestration of metals, like metal ions, like metal elements like copper, zinc, lead, uranium, and cadmium from contaminated environments. So which is very useful for the industrial areas, because of which have contaminated our environment, soil, groundwaters. So these plays again a major role for decontaminating the industrial areas. And the nanoclays remove metals and ions, as we discussed, from the environment and also enrich the ecological health of the environment. If you see this, I think we feel very happy. The desert to fertile land. So I hope very soon our whole world has to, convert like this to make our all deserts to fertile land. So nanocomposites. So let us discuss about nanocomposites. These are nano-sized particles into matrix of material. The nanocomposites are polymers with biocompatible and biodegradable features that make an ideal system for the delivery of micronutrients for crop protection. Nanocomposites are classified into different types. Polymer matrix nanocomposites, which are, if you see, the nanocomposite polymer or carbon nanotube, or polyester, titanium oxide, and thermoplastic thermosetting, as well as ceramic matrix nanocomposites also are there. Metal matrix nanocomposites also there. So I think you'll have this will be polymer matrix, and these will be the interaction zones, and these are the nanoparticles. Yellow, these are the actual nanoparticles, and in red you have seen the interaction zones, and which are in the green it is a polymer matrix. So in the matrix these nanoparticles are bounded. So I think this you can better understand how nanocomposites will bind together in different forms. The nanocomposites have antibacterial effects, such as disruption of the bacterial cell membrane, because it will very efficiently they can go into the barriers of cell membrane, penetrate the cell, and interact with the DNA or proteins. Nanocomposites have a potential applications in agriculture, which include plant growth, antibacterial effect, pest management, and alter the soil microbial community. The polymeric nanocomposites enhance the utility of genetic engineering tools in the plant system. Those who would like to work in the nanobiotechnology area, so this is a very good area to work on. The nanofibers are materials or polymers, both inorganic and organic. The nanofibers are nanometer range in diameter with unique properties. As I said, I think they're having a high, because it is a very long, so their surface area is high, and high mass transport and high nanoporosity. So even porosity also very important to be a carrier. So for the preparation of the nanofibers, electrospinning in the technique used to make them suitable to be used in various fields. The nanofibers are made of from acrylic, fluoropolymers, nylon, polycarbonate, and polysulfones. So the biological polymers are again the chitosan, polylactic acid, glycolic acids. I think which are very much accessible to the scientific community to work on. And if you look into the advantages of the nanofibers, they can penetrate into the seed coat and also have a translocation ability. So which will make them to seed to germinate. The carbon nanofibers translocate from root to shoot to leaves with the plant system. So I think the apoplastic or symplastic mediated transportation, it is from these carbon nanofibers, it will go in different way. So which is very useful for the plant metabolism. Whereas the carbon nanofibers slowly release metal nanoparticles into the plant, and because metal nanoparticles or metal ions, we will have slow or low mobility in the plant system, in the transportation system. So these nanofibers slowly release metal nanoparticles to alleviate from the nutrient deficiencies, especially micronutrient deficiencies. They increase the germination rate and water retention capacity, and it acts as a stimulant a growth stimulant in plants. The carbon nanofibers are the new generation fertilizers that increase the nutrient uptake and act as defense regulators. So they protect the plants from pests, insect, and disease-causing microorganisms. The encapsulated nanofibers also deliver the pesticide molecule in a predetermined manner. So that is a very interesting point to know. The plant growth promoting bacteria, so we are all aware, are encapsulated in the nanofibers and are applied to the plant for enhancement for plant growth. So this is a very interesting thing. So I think from one startup from IIT Madras, I think we met in a couple of years back. That time itself, they already worked and they have released their products in the, in the market. So they are, and personally, I've used and I've seen the results. And actually, if you go to the market, if you see the biofertilizer or plant growth promoting, you need to apply 1 liter or something and half liter per acre or something. But whereas here in using the nanofibers, it will be just like a small vial, which will be enough for entire per acre or per hectare. So personally, I've used and I've experienced it. It's a really wonder. So this is also very interesting. Application of nanofibers. The same thing, nanotechnology in agriculture, from starting onwards to seed storage or seed germination, seedlings, and how it has up to post-harvest technology, different stages, different phases of the agriculture. So again, for your better understanding, how it has, from 1 nanometer to 100 nanometer, and its surface, its material, and its shape. So, entire presentation I would like to bring it as a reminiscence, or for your better understanding. So how it will be. So the size varies from 1 to 100 nanometers, and its surface, how it is, surface area and surface charge. That is very important. Even the shape, how it is, and if whatever you are targeting, so the shape also very important. It can be a cube, sphere, or rod, or that again material. What material you are having? If it is a liposome, or it is a particle, or metal particle, or even carbon nanotube. So thank you so much.